Hi everyone. So today I would like to talk about a project I recently made. So I released a small web game which is a clone of the classic game Duck Hunt. So it's called Duck Hunter and you can play it using the link in the description below. Now that game has been released for a while and I think it's the perfect moment to reflect on what I learned building this project. But before we get started, I would like to first present the game. So, as with the original duck hunt, the goal is to shoot as many ducks as possible using a cursor. So, in my game, it's done with the mouse, but in the original duck hunt game, it was done with a gun like accessory called the NES Zapper. So, every hunt, a duck will start flying around, and you have three bullets, and a limited time window to shoot it. So there are 10 hunts per round, and if you fail to successfully shoot a duck in a single hunt, the dog will laugh at you. So once a round ends, what happens is that another round starts only if you were successful at least with shooting 5 ducks in the previous round. Otherwise, it's game over. And also, once a new round starts, the duck speed will increase as a way to increase the challenge gradually and make the game more challenging. So that's the gist of it. I made this game using the JavaScript programming language and the Kepler game library. So in case you're unfamiliar with Kepler, it's a very simple and easy to use JavaScript and TypeScript library with many built-in features which enables developers to make 2D games quickly. I really recommend giving it a try. So let's start with what I learned. So first I'll talk about what I learned in terms of game design. So the main game design lesson I learned is that your game should always be built upon a few simple mechanics until you obtain a solid foundation. So by solid foundation, I mean that the game is fun to play even at a stage where there aren't a lot of mechanics. The reason for this is that there is this sentiment that you need a lot of complex systems, mechanics, and content to make a good game. However, when I was remaking the classic Duck Hunt, I realized that a game can get away with very simple mechanics and still remain fun. However, I must concede that more complex mechanics, features, and content make a already fun game fun for longer. Also, considering that you do a good job and not, make your game bloated. So that's why after making this project, I now believe that I should always start with a simple game at first. So only a simple version with really not a lot of mechanics, and only when this is done and I have realized and made sure that the game is actually fun at that stage, then I will focus on adding more mechanics, systems, and content to make the game remain fun for longer. So this sentiment is also echoed by one of the comments I received on my game. So I published the game on itch.io, which said basically that great job setting the formula down plus tutorials. Got to share this around. So yeah, I made a link towards the tutorials I make on Kaplay. By the way, you can check them out in my channel and also on my Substack, linked in the description. So if you and what the comment says afterwards is that if you're developing this further, would love to see more formula mix-ups, got a pretty solid foundation here, which is the comment that made me think that, hey, what I should do now is always make simple games at first, and then depending on the reception, I can now decide which one to pursue further and add more detail, more mechanics, etc. So now let's jump out at what I learned in terms of art. So despite this being a clone, I wanted to make my own art for the game. And to do this, I took heavy inspiration and sometimes just recolored some sprites of the original Duck Hunt with a different color palette. So the main lesson I learned while making the sprites for this game is that sticking to a limited color palette is key to having a good end result. So this is pretty common knowledge. However, you shouldn't be afraid of expanding the color palette if you absolutely need it. So this is something I learned really in this project. Because at one point, I took a pre-existing color palette and I didn't have a color that would represent the sky well, so I had to add it on top of the existing color palette. And this is also why I realized that it's in fact much easier to expand a given color palette one color at a time than to not have a color palette initially and then just choose colors on the fly. So what you need to do is simply, when you need a new color, like you really need a new color, you can more easily compare your new color choice with your existing color palette and then see if it fits and change it if not. So when it comes to picking color palettes, I really like the site LowSpec. I recommend going on there. I will link it in the description. It's really a helpful site for picking the number of colors you want, and you have examples as well of each of the color palettes, not all of them, but you can have a good idea if a color palette will look good in what you want to achieve. Now, the important part of this video, what I learned in terms of programming. So it's not that the other parts weren't important, but this one I would say is probably why you watch my channel. So in terms of programming, it gave me a chance to reflect on my tech stack choices. So as I mentioned earlier, I used JavaScript alongside a library called Kplay. And you might be wondering why this stack, why JavaScript plus Kplay. So if you're mostly asking this question if you're new to my videos, so let me explain. So my background is in web development, and JavaScript isn't used that much in game development, in proper game development, the AAA and actual games you buy on Steam. It's still used, but not as much as C#, etc. And you might be wondering why I decided to go with this route. So my background is in web development, and precisely in full stack web development. I originally wanted to start game development just as a side hobby, and I could not justify the time investment in learning a new game engine or a different programming language just to try something I wasn't even sure to like. That's why I decided to just use the tools I already knew, and this is how I got my start into game dev in JavaScript. And even to this day, I like the combination between JavaScript and Kplay because it allows me to move quickly. So Kplay, despite being a library, has enough built-in features that you don't really spend time reinventing the wheel. So collisions, input handling, physics, etc. are all included. The only thing that's not included, I would say, is that for bigger games, what I consider really essential is an editor for placing things around for your levels. However, I was able to mitigate this drawback rather easily by using an external program called Tiled. So another strong point of this stack is how easy and responsive the development environment is. So since your game is only appearing in a browser window, it's very easy to have fast refreshes and reloads. So when you make a change, you just hit save and immediately your game is reloaded in the browser tab, and you can easily be very productive when developing your game, because you can see changes very, very quickly. So that's the idea. So why not TypeScript? So if you're familiar with web development, you also might be wondering why I'm not using TypeScript instead of JavaScript. So TypeScript has been establishing itself as the best option for web development due to the added safety and readability in big code bases compared to JavaScript. However, as someone who used TypeScript professionally, I do agree that TypeScript overall is good, but the only reason I did not use it for most of my projects is because I originally made these projects and games just to make game development tutorials on YouTube. And after having made a few TypeScript game dev tutorials, I quickly realized that on YouTube, using TypeScript will result in considerably less views compared to JavaScript. And now that I have changed the way I do YouTube, I no longer feel compelled to use JavaScript exclusively, so I will probably switch to TypeScript for my next few projects and then compare my experience. So another thing I learned is how useful finite state machines are in game development. So while building this game, I realized that I reuse a concept over and over again, and not just in this game, but in my previous project as well, is state machines. So finite state machines, to be more precise. And I found myself using them to handle animations, build enemy AIs, implement cutscene logic, and handle general game state. So for those unfamiliar, a finite state machine is a way to model a program where you define a set numbers of states, and for each of them you define the logic that runs when entering, when exiting, and while remaining in that state. They make a certain aspect of game logic easy to organize and maintain. And to make things less abstract, let's look at how I used state machines in my Duck Hunt clone. How I made the intro cutscene is a good example. Before the game starts, we can see a short cutscene where the dog is moving forward and sniffing around to find ducks. Once a duck is detected, the dog jumps into the grass and the game starts. So to make this cutscene, I needed to move the dog and play the relevant animations in a deterministic fashion. And I also needed a way to determine when it was appropriate to run this cutscene. So this led me to create a state machine for handling all of the game's state. So the diagram here shows how it is structured. So we have multiple states, so the menu, the cutscene, the round start, hunt start, duck escaped, duck hunted, and depending on what happens in the game, we go to a specific state and run some logic, etc. So you can pause here if you want to take a look. So when using Kepler, you can create a state machine using the following syntax. So you have here the first param is the menu, not the menu, the initial state you want to use, and then the second param is all the states you want to use. So I'm aware that not everyone is familiar with the Kepler's API, so that's why I have passed over a couple of concepts here to understand the code. Just know that you define it this way in Kepler. And then when you do this, Kepler will give you access to certain methods to be able to run logic when, for example, on state enter, when you enter a state, when you are in a state, so every frame using on state update, and then allow you to enter different state from within other states using the enter state method. And now, because we have this, it makes us putting our logic into specific blocks like that really good for maintainability and knowing what is happening in the game. So it makes implementing complex game states easier. I also used another state machine for the dog movement, and this was mainly used to know how to move the dog, when to move it, and also what animations to play, what sounds to play, etc. So here on the screen you should be seeing a diagram which represents the second state machine I made for this project. So that's basically all my learnings for this project. I hope you learned a thing or two. If you are interested in learning JavaScript and TypeScript game development using the Kepler library, check my channel out. You'll see plenty of resources and tutorials and etc. and videos you can benefit from. Also, in addition, I do written tutorials and so written tutorials and guides that explains how specific things work in Kepler. And if you are interested in that, check out my Substack and subscribe on it. So you receive the content right into your inbox. So thanks for watching. Bye.